Hi, my name is REN-HE Su. I'm from Sichuan Normal University, Chengdu, China. Welcome to the video abstract of my paper on plus space for Jacobi forms of Hopf integral weight and the matrix index. In 1975, Cohen introduced the following modular forms HK, which is of Hopf integral weight, k plus 1 Hopf, and here k is an integer. And here, these Fourier coefficients, h of k and n, are the so-called generalized class numbers, and they only occur when -1 to k times n is congruent to 0 or 1 mod 4. In 1980, Cohen brought out the plus space n plus and s plus, which are consisting of modular forms of Hopf integral weight k plus 1 Hopf, and are characterized by the Fourier coefficients of the forms inside. The modular forms introduced by Cohen are considered the Eisenstein series in the Cohen plus spaces. In 1985, Eichler and Zagier showed that the Cohen plus spaces are isomorphic to the spaces of Jacobi forms of weight k plus 1 and index 1. And these isomorphisms are via the theta decompositions of the Jacobi forms. These isomorphisms are Hecke isomorphisms. And here are some generalizations of the work from Eichler and Zagier. The case of integral weight was considered by Kojima in 1982. The case of Siegel modular forms was considered by Fukuyama in 1986. The case of Hilbert modular forms was considered by Hiraga and Ikeda in 2012. The case of Jacobi forms of Hopf integral weight and matrix index with underlying field Q was considered by Hayashida in 2018. And here comes the work of this paper. In this paper, we generalize the result from Hayashida to the case for general totally real number field. We define the Cohen plus space J plus k plus 1 Hopf and n of Jacobi forms of Hopf integral weight k plus 1 Hopf and the matrix index this m by conditions on the Fourier coefficients, and then characterize it through Weil representation. By applying representation theory, we will see that the Cohen plus space of such Jacobi forms is isomorphic to the space of Jacobi forms of weight k plus 1 and this matrix index M. Here, this matrix N is of course conditioned by this matrix index, this M. We know that this isomorphism is a Hecke isomorphism. And that's all for this video abstract. Thank you for your attention. 可以了。